Welcome back. Today we'll be doing a negative exponents. Negative exponents simply mean take the reciprocal, or I belong on the other side of the fraction. So, for example, x to the negative fourth power. You have to think to yourself, what's being raised to the negative exponent? In this case, the base of the negative exponent is x. So that's what we're taking the reciprocal of. So now think to yourself, what is the other side of this fraction? When the denominator is not written, it's 1. Since x is being raised to a negative exponent, that means put me on the other side. Therefore, x to the negative fourth is 1 over x to the fourth. Notice the base that has the negative exponent moved to the other side of the fraction, and the exponent became the opposite sign. The base didn't change, the number of the exponent didn't change, just the sign of the exponent changed as soon as it crossed the fraction line. So if we had something like 2 to the negative third power, well, again, the other side of this fraction here is 1. So the base of this exponent is 2. The exponent is negative 3. So this is telling me take the 2 and put it in the other side of the fraction. 2 to the negative third is 1 over 2 to the positive third. So the 2 has the negative exponent. Put the 2 on the other side of the fraction and make the exponent the opposite sign. So 2 to the negative third is 1 over 8. If we had something like 2x to the negative second power, now the base of the exponent is going to be really important for this example. The thing that's being raised to the negative second power is x. So the 2 is not being raised to the negative exponent. Only the x is. The exponent of 2 is 1 here. It's not written, but the exponent is 1. The base of the exponent, negative exponent, is x. Therefore, the thing that's moving is x. Let's write the other side of the fraction so we could visualize where the x will be going. So since the x has the negative exponent, that's what's moving to the other side of the fraction. The 2 has a positive exponent, so it remains in the same side of the fraction. Therefore, the 2 is in the numerator, and the x term is in the denominator. The exponent was negative 2. As soon as it crosses that fraction line, it becomes a positive 2. Now, that last example is pretty closely related to this example. Before, the base of the exponent was only x. 2 had an exponent of 1. In this case, the negative exponent has a base of both 2 and x. They're both being raised to the negative exponent. Therefore, we are moving both of these terms. So we're going to move both of them. But don't forget, they're both being raised to the positive second power now. As soon as that exponent crossed the fraction line, it became the opposite sign. So now this means that 2 and x are being squared separately. So we can square 4, and we can square 2 separately. So now, negative exponents could have a couple of different goals. You can express with no denominator, or you could express with only positive exponents. If we want to express with no denominator, now the directions will tell you what your goal is. These are just examples leading into what negative exponents do. Simply put, a negative exponent says, take the reciprocal of me, or I belong in the other side of the fraction. So if we want to express with no denominator, 4x over y to the fifth. Well, the denominator here is y to the fifth. If we want to express with no denominator, that means we want to take this y term and move it up. But just with our preceding examples, as soon as you cross that fraction line, the exponent becomes the opposite sign. Therefore, we can say that this is 4xy to the negative fifth power. Let's do another example of that. Let's express with no denominator 3x squared over 2x y to the third power. So now we want to take all of this and move it up. But before we do that, we can simplify some x terms here. So let's express this as 3 over 2. X squared and x cancel, leaving us with only an x in the numerator. And the y to the third is still in the denominator. So now these are the two things I want to move up. 2 has an exponent of 1, even if it's not written. Now, as soon as these cross the fraction line, the exponents become the opposite sign. So we're going to express this as 3 times 2 to the negative first times x times y to the negative third. And the order of this is not important. Now, if we want to express with only positive exponents, let's say we had x squared y to the third z all over x to the negative third y squared z to the fourth. Now, expressing with only positive exponents means whatever's negative, get rid of it. So in this case, this is our only term with a negative exponent. But we do have other terms that we can simplify. So the directions here, expressed with only positive exponents. So these are all exponents that are positive. So this is the only one that's giving me trouble. So now the negative exponent says, move it. Where? To the other side of the fraction. So there's already an x squared there. Now there's another x to the third. Because as soon as this negative exponent crosses the fraction line, the exponent becomes the opposite sign. Let's rewrite what remains in our numerator. And then we'll just copy what's in our denominator. Y squared z to the fourth. So now we can combine these, we can cancel these, and we can cancel these. So x squared times x to the third is x to the fifth. There's 3 y's in the numerator, 2 y's in the denominator, leaving you with only a y in the numerator. There's 1 z in the numerator, 4 z's in the denominator, leaving us with 3 z's in the denominator. Now, if I wanted to revert back to this example where I wanted to express with no denominator, I could express this as x to the fifth y z to the negative third. But in this case, we want only positive exponents. So now let's see why a negative exponent means take the reciprocal. Let's simplify the fraction x squared over x to the fourth. Now, referring back to our properties of exponents, x squared means x times x, and x to the fourth means x times x times x times x. So now the only operation present in the numerator and denominator is multiplication. That means we can cancel an x with an x, and we can cancel an x with an x. When there's nothing left in the numerator, it's a 1. And there are 2 x's left in the denominator, therefore it's 1 over x squared. So we know that we could simplify x squared over x to the fourth to become 1 over x squared. But other properties of exponents tell us that when you're dividing exponents with the same base, you subtract the exponents. And 2 minus 4 is x in the negative second power. Therefore,